Yeah, I do that as well for the youth. So I'm like, oh. All right. So to respect our time real quick, we're going to get into the power rules. My goal is to finish 12:2. I don't know if we'll go any further than that today. But go ahead and start those chapter 12, and then we'll try to finish chapter 12 on Monday, and then 13 on Wednesday. And then whatever I don't get finished will be pushed out as some little videos. All right. So the one thing we did not talk about, I showed you, but we didn't actually do an example, is a power raised to a power we will multiply, right? So again, for example, if I have x to the second power and I raise it to the third power, I'm going to do 2 times 3, which will give me my 6. Go ahead. Oh, yeah, yeah. I just don't like the calculator on the test. Using it in this is fine. Yeah. Yeah, perfect. Yeah. I actually have I think I have like 3 calculators downloaded on this phone. I got an old school 84. It's called Wabbit, the W. I don't know, I found it. I was like, "Ooh, I like it." And then I like Desmos. Desmos is such a great calculator, and I wish it was in this program because that's a good one too. So this is the one thing we did not get to talk about. So we'll do some examples with that. So knowing this, what would x to the third raised to the fifth equal? Oh, absolutely. Hold on. I'm sorry. It's bothering me. I gotcha. Oh, green good? Green's good. I gotcha. Oh, you're good. I gotta know these things. I just change colors to kind of change like things that are happening on the screen. Well, that's good. You want me to rewrite out this? Okay. Yeah. Raised to the fifth power. That's it. That's all it is. So it does. Definitely gets harder. Starts off basic and then definitely progresses. All right, so let's look at another one. Let's try x to the fourth times -3. Yep, x to the fourth raised to the -3. Mm-hmm. Which is -12. What's wrong with this? There it is. So it becomes 1 over x to the 12th. What is it? Are you doing like an iPhone calculator? It's going to be the plus minus looking button, I think. Bottom left-hand corner. Yeah. You have to, I think, you have to type the number first, or can you hit the button regardless? And then you make it a negative, yeah. And believe it or not, it took me a while to figure this out, but if you're on your app, like this is your calculator. Oh, no. Oh, is that what it is? Oh, then you can make it scientific. Okay. Beforehand, it used to you do this and it would become scientific. Okay. Yep, they got an update here. There's math notes. That's kind of cool. All right, well, got distracted. All right. So good. All right. So let's look at one like this. That's it. We made it a positive exponent. We were golden. Yeah, so when it's negative, that's why we make it a fraction. Oh yeah. These are, I feel the, oh, I'm writing the same problem. Hold on. Y to the negative fifth raised to the third. Just punch the table. Okay. Okay. There it is. Looking good so far, guys. 3 squared raised to the negative 3. Yeah, the big 3 would stay the same. Mm-hmm. Okay, good. So I will say that's a misconception. They want to add, but make sure power to a power we multiply. So it would be 6, but is it a positive or negative? So a positive and a negative would make a negative. So this is a 2 times a negative 3. Gives us a negative 6. But then that becomes how? There it is. So it becomes 1 over 3 to a positive 6. But on this one, you can still go further. I'm going to take your word for it. I can go to about 81, and now I guess I can go to 243. Yeah, 729 is not off. Yeah, 243 3 times. Yeah. Yeah, I trust it. But yeah, so just remember that when it's a number, they do want you to go all the way to whatever the value is. And this is technically you could technically use your calculator and type this exact thing in, and it will shoot this back out to you. Yes, because of the negative right here. Yes. Or alternatively, like y'all leave it like this. Or I see a lot of times y'all do 3 times 6, which is 18. So just watch out for that. Times 3. Mm-hmm. Left, maybe. Probably got the kids. Dogs know that ringtone too. They'll start going crazy. All right, so let's take it to another extreme. Let's take 4x raised to the second power. One thing I want you to notice here is that the 4x is in the parentheses. So what happens, I mean, what do you mean by that? No. So you could see this as 4x times 4x if you want it to, because there's 2 of them. But what I want you to see, because it's going to get super complicated later, is you take this exponent and you apply it to both. And what that means is you'll multiply letters exponents. So 1 times 2 gives you 2. So this will be x to the second. That part's the same that we just saw. But this becomes 4. That also has an exponent. So it becomes 4 to the second. So it's no longer just going to be applied to the letter. It's applied to everything inside. Yes, 4x raised to the second power in parentheses. And so both of these had imaginary 1s as exponents. So when I multiply them, I really have 4 to the second power and x to the second power. Mm-hmm. Mm-hmm. But you're still not done. because you have to evaluate that 4 squared. There it is. Squared, second power 2, whatever you want to call it. As long as you know it's a little bitty 2. We good? And that would be it. So let's try this one. X times y raised to the 7th. There it is, because you have to apply the 7 to both, and there's imaginary ones on both. So that'd be x7, y7. And that would be it, because there's no numbers. Let's see how you do with this one. -9 AB raised to the 2nd. All 3, very good. What would that look like? Caution, you said -9. Would that still in parentheses when you apply the square? I only say that because on your calculator, if you don't put it in parentheses, the answer is still going to come out negative, and it's going to need to be a positive answer. The rest of it's fine. I can say A2, B2. Only when it's a negative, because when you type this part into the calculator, you'll get the correct answer. If you don't have it in parentheses, what happens is the calculator will apply the square first, then the negative, versus saying -9 times -9. Your calculator will go, oh, 9 times 9, then the negative. And you don't want that. You want that negative applied twice as well. Good. So it'll be positive 81. And I'll show you the difference here in a second. Like, so if I was to just do -9 squared, notice it gives me -81. That's incorrect because it's really -9 squared and it's positive 81. So that's why I say if it's a negative number, keep it in parentheses so that the calculator gets it correct. Because here, it's not that these are 2 different answers because these are 2 different questions. But this square is only being applied to 9 without the parentheses. So it does the 9 times the 9, then applies the negative. This being in parentheses, the calculator goes, oh, you want me to do -9 times -9. And that's the 81. All right. So like, no, yeah, it went away. But yeah. Mm-hmm. Perfect. I do have a question. Yes. So let's say it's -9 times 50. It would be, yeah. So anything to an odd exponent will remain negative. Anything to an even exponent will stay positive. Or become positive, I guess. All right, let's try this one. A times B raised to the -3. Both? Mm-hmm. Mm-hmm. Perfect. But then we can't have negative exponents. So what happens to both of those? They both will go over 1 since they're both negative. And then they become positive. And they're back home. No, the church is only like a mile from our house. They just picked up the kids. Good there? All right. One more in this style, and then we'll go one more step with it, or a different direction with the steps. Let's take x cubed, y to the negative fourth, so actual exponents going on here, raised to the second power. You would still distribute, the rule hasn't changed. It would be x6. A power to a power, we want to multiply. So 3 times 2. Oh, that's my phone. And then it'd be y to the negative 8. Is that the correct answer? What do I still have to do? So what's on top? What's on top? Would I move both? This one I had to move both of them because they were both negative. But this one, which is the only one that would move? Correct. Because a negative exponent is the only guy that has to move. Since x is 6 is positive, he gets to stay on top. And to make this negative become a positive, I have to put him on bottom. Yes, I think you had the right idea, but you had it backwards. Yeah. Correct. To become positive. We can't have negative exponents as our answer. Are we good there? All right, let's try a different direction. We have x over y raised to the 7th. What do you think we're going to do in this situation when it comes to division? Mm-hmm. That's it. Even if it's multiplying or dividing, it doesn't matter. You're still going to distribute to wherever those letters or numbers are at. So in this case, you are correct. X7 over Y7. Misconception. A lot of kids, that's exactly what they do. They only do it to the top of the fraction and ignore the bottom, but it has to go to every single term, top and bottom. All right, let's see how you do with this one. 5/6 raised to the second power. What's the same thing look like to me or to y'all? Oh, woo. Exponent. Okay, good. But that's a misconception because students will do that. They'll go 5 times 2 is 10, 6 times 2 is 12, and that's incorrect. That's 5 to the second power over 6 to the second power. And it's not done yet because I have to evaluate that. Right? I'm telling that, but that's what students will do. So 5 squared would be 25 and 36. Mm-hmm. If it could have been simplified, it would have been simplified at the very get-go. So like for instance, if this would have said 10/6, I would simplify that first to 5/3 and then multiply. If we get a situation like that. I'll explain that one. All right, let's see how you do with this one. 3 over a raised to the third power. Okay, what's that look like? Okay. It does look like a die. you go. 27. Very good. A3. Not a 9. A cubed. That's a good practice there. That's how a lot of my letters changed was in notes. We'll have to do that. Hmm. All right. One more of this style, and then we'll go a little bit more advanced. X over 6 raised to the third. Hmm. There it is. Perfect. Perfect. Is that what it is? Yeah. I'm about to say it's 36 times 6. That sounds right. 36, 6, 6. 216 sounds right. Ooh, good point. Good point. Yeah. All right. So let's make this a little bit more challenging. Let's look at negative 3x over y cubed raised to the third power. Okay. Mm-hmm. When you say all, what's that mean? Very good. When, very good. So this is still a power raised to a power, so you'd want to multiply. So ultimately, what's the answer look like right now? What am I going to do with this negative 3? To help me make sure I don't make an error in the calculator, I'm going to put it in parentheses. So raised to the third to the in parentheses to the third power, because in the next step we need to evaluate that. I'll write that here in a second. I need the rest of it though. X to the third power. Y9, perfect. So yeah, so then that would be negative 27 x cubed over y9. Because a power, so the rule is a power still raised to a power, even if it's a fraction, I'm still going to multiply. Yeah, so all I did here was evaluate this guy. Now, if you do that right off the bat, I'm good with that too. I'm going to, as y'all's teacher, I'm going to write every step out. All right, let's see how you do with this one. 4a cubed b squared over a4b raised to the second power. There is a couple approaches here. Yes, no nines. No nines. No nines. Oh. Okay, I see what you're doing. You're not off. That's a legit step, and you could do 6 and 4 and get all that stuff. Here's my recommendation. so that you don't have to do so much multiplying, especially the harder they get. Simplify inside first, then apply the 2. Now, you're not wrong on what you're saying. If you want to go ahead and make that 4 squared a6 b4 over 8a b2, you can do that. But then your next step would be to simplify it again, because that would be what you would have to do. My recommendation, simplify first, your numbers stay smaller, and then you can multiply those. Kind of. I'm going to do what we did in 12.1 when I pretend the square's not there. This is back to 12.1 division problem. I'm going to simplify the coefficient, I'm going to simplify the a, and I'm going to simplify the b. So in this case, 4 is not being divided by anything, so it's just going to be a what? A 4. So I'm going to keep my parentheses and 4. Ooh, what do we do when we divide? We subtract. 3 minus 4 is... That's it. So it'd be -1. Mm-hmm. 1. And you can write the 1 if you want, because it's your pre-work if you want to. This isn't your final answer. So I'll write the 1 right there to know that 2 minus 1 is 1. Mm-hmm. So now looking at this is a lot less of the distributing of 2 than it was over here. So now when I go through this, I get 4 to the second power. And then I get a, what's -1 times 2? -2. And then oh, okay, that's perfect. You can go as fast as you want. I'll catch up eventually. Remember, you're multiplying a power to a power, so it'll be 2. Now there's 2 things still wrong with this. Ooh, love it. The only thing that moves is the a. So this becomes 4 squared b squared over a squared. But you're that's fine too, because then what is 4 squared? So 16. So your final answer is 16b squared over a squared. All of these are a's, no 9s. So that would be the final outcome. Now, again, you're not incorrect if you wanted to go ahead and distribute those. Alternatively, you would have 4 squared a6 b4 over 8a b squared, right? Yeah, and then you would go through and you would apply all this. This would be 16. This would be 6 minus 8, which is -2. This is 4 minus 2, which gives you 2, which gives you right back where you were just at over here. So you're not incorrect either direction. Whatever you feel more comfortable with, go that way. I like when I multiply to make those numbers as small as possible before I go through it. Yes. Yeah. And then that negative was only attached to that A. So that's why that one was the only one that moved. All right. Let's go back a little bit to something simpler. Let's look at x to the 6th over y to the 3rd raised to the negative 5th. Okay. Like you're talking about the final answer? Yeah, so what would that be? Negative 30. Perfect. There you go. So you apply it to the y and it becomes negative 15. All right, but we also have a negative on the bottom. We haven't seen one like this before. So we have a negative on top, bring it down. Love that. If there's a negative on bottom, what do you think we're going to do? Oh, that would be if these were both the same terms. This is an x and a y. Cannot actually subtract them, but that's not a bad concept. So I love this idea. I got going no orange, pink. No orange. All right. So I love the idea. Yeah, I thought that was red again. This right here comes to the bottom. That's what would make it positive, right? So I love that idea. There it is. So if you have a negative on the bottom, instead of coming to the bottom because it's already there, I'm going to take it to the top. And when I do that, it will then go back to a positive. So then this would be the final answer. That's a good one. So if you ever end up with a negative on the bottom, bring it to the top. All right. So I'm going to throw the most extreme question I saw in your homework out. It is. Be ready. 3x to the 3rd power, y to the 2nd power, divided by 4x, y to the negative 3rd power. All of this one is raised to the negative 2nd power times 5x to the 3rd power, y to the negative 2nd power, divided by 2x to the negative 4th power, y squared, divided by, or raised to the negative 2nd power. So the x, on the bottom? Yeah, no exponent on that x. Simplify it, right? Good. So this is like having 2 questions in one. Let's simplify my numbers and letters. So 3/4. Ooh. How would I simplify 3/4? You could convert it to a decimal if you like. I think it's going to be easier to keep it as a fraction for your homework purposes. But coefficients, I don't subtract. I actually divide them. But 3/4 can't do anything. So it's actually going to stay 3/4. Now I made this a long fraction because I know I got some x's and y's I got to add in here too. So now what's going to happen to my x's? There's an invisible one. Very good. So when we're dividing, you want to subtract the exponents. So it'd be 2. Mm-hmm. Perfect. In this situation right here, this is 2 minus a negative 3. That would make that a positive. So that's why that became a 5. You may make that bigger. Hold on. So this would have been 2 minus, well, that's too big. Hold on. Let me find out where to put this. This answer right here comes from 2 minus negative 3. So that's why it became a positive 5. You could. I'm going to simplify this one too and bring them kind of down at the same time as I work them down. You could, though, you go ahead and distribute this, get to that answer, but then it's going to be applied to this answer as well. Go ahead. Because when we are simplifying them, we're making them just one letter. So I did 3 minus 1, and I got 2. There's only x2 on top. There's nothing left on bottom. So like like here, when I did the A's, it became an just an A and just a B. There was nothing left on bottom. The only reason why this looks different is because I had a 3/4 that couldn't simplify. So there is a 4. There's still nothing there, though. And now we're going to apply it to here. 5/2. I'm still dividing. There's nothing I can do with that 5 and 2. Very good. So again, this value right here is 7 because this is, which gives you that positive. And then what's this one going to be? It is. And then that one comes from the negative 2 minus 2, which is negative 4. And then all of this is still raised to the negative 2. Now I'd recommend distributing to everything. So I'm going to take. So in this one, there's the 3/4. You could have it as one fraction, but then you would have to reapply it anyways. Treat them as separate numbers. Mm-hmm. Mm-hmm. Oh, this one here. So yeah, x to the negative 4. There it is. It's still there. Yeah. I was just saying treat them as separate numbers and not 3/4, but 3 and a 4. Yeah, it could be over 4 to the negative 2. Mm-hmm. You're good? Nope. So this one, we would apply it to the exponent, not actually add them yet. We haven't done anything there yet. Yeah. So now I got to do this one. So then this one, I just, well, it could do that. Like you go all the way down, then come back and do all these, and then we'll do that last step. Negative 2. Mm-hmm. Very good. There we go. All right. Yes, because -4 times -2, two negatives will give me a +8. All right. Now, here's where the fun somewhat starts, but not finished. Anything that's a negative, we need to make them not negative. Well, let me think about this. Hmm. I would just get rid of all these negatives. So what will happen in this situation? They're all negative exponents. What would I do? I'm literally just going to flip the entire thing. So now it becomes 4 to the positive second, good, over all this. But make them all positive. Now, I wish I could do the same thing here. But in this situation, what's going to move down and what's going to move up? Very good. So the y to the 8th will stay. There you go. So now, sorry. So this become 2 to the second power, y8 over 5 to the second power, x to the 14th. Getting there. All right, so before you can multiply, remember fractions, as a reminder, fractions you multiply straight across. So everything on top is about to multiply with everything on top. Everything on bottom will multiply everything on bottom. All right. So 4 squared is what? 16. So this becomes 16 times 2 squared, 4. And then I just have a y8. I did put a multiplication sign between the two numbers, so I didn't look like I had 164. 3 squared, 9 times 5 squared, 25. I am trying to keep my numbers together, so that is why I wrote the 5 squared next. Now I'm going to put the letters. But I do have an x to the 4th times x to the 14th. What will I do with those two numbers? If I'm multiplying, I'm going to add them. So 4 plus 14 is 4 plus, oh, I wouldn't add this one. This is a y. So I'd add 4 and 14. They have to only add the same letters. So it'd be what? 18. Good. You good? And so then I have the y. There's nothing to go with the y. So y 10. And then the process continues. 8. This is our last one. Yeah. So 16 times 4 is, oh, is it 64? Yes, you're right, because 16 plus 16 is 32, so 64. Yeah, absolutely. 9 times 25. 225. I was trying to do quarters there for a second. It's like, well, what's 9 quarters? All right, so 225. X to the 18. Now this y, we have two y's here. We can still simplify this. So 8 What am I going to do with this 8 and this 10? So 8 minus 10 would be 2. Last step. What is still wrong with this problem? What am I going to flip? Ooh. Good. So this one we had lots of negatives. Yeah, so everything's going to stay except the thing that has a negative. So that one will come down. So ultimately, our final answer is 64 over 225 x 18 y 2. All right, 64 and 225. Like I said, if you could have simplified, it was simplified at the very beginning. There's nothing to simplify there. And that is all that I have. Right? This is 1 and 2.